Hello everyone, my name is Peter Schaknat. I am the Managing Director of Schaknat Electronic GmbH, and today we are optimizing a Mercedes-Benz Actros 1848. Today we have a beautiful Actros MP5 here, the 1848 model. This is the first generation of the MP5 series, equipped with an OM471 engine, 12.8 liters. These engines are available with 420, 450, 480, 510 and 530 horsepower. So we have the mid-range model. Today, the customer will receive an engine and transmission optimization with our new Schaknat App, and in combination with the test bench. Primarily, as I discussed with the customer beforehand, the focus is on fuel savings and transmission tuning. Because the customer has complained, particularly with the 480 model, he drives silo transports, including some very heavy loads, that the transmission and the engine don't appear to work together in perfect harmony. And he also believes that if the torque is adjusted at the lower end, as is actually the case, the shifting becomes smoother and, as a result, fuel consumption improves. Today we're measuring the rear axle again. As you can see, we've already set it up. This is our daily business. Completely standard 4x2 tractor units. They have a standard axle, a lightweight hypoid axle. Here, from the engine through the drive shaft to the axle, you have the least resistance. This also applies to the new axles. We're now consistently noticing this on the test benches as well. The resistance within the components, whether it's the transmission, axle, or engine, is continually decreasing, so the vehicles are able to roll more freely. Of course, a semi-floating axle like this has significantly less power loss. This vehicle is also equipped with the PowerShift 3 transmission, and it still has a Euro 6D engine, so the previous generation engine, with the old shifting strategy as well. You've already seen that in other videos by now. This is truly the new third-generation engine, also featuring the brand new transmissions. The new ones already come with 16-speed transmissions. Mercedes has definitely made significant improvements to the shifting system. The vehicles drive really well, even the Picobello models. They already shift very smoothly too. What they don't have yet, well, that's why with our app you can individually adjust the engine and transmission, so you can really go in and say, in the areas where the customer says they need a bit more or less, or more comfort. Many customers, when I'm driving long distances, I don't want any jolting or jerking. I'm the same way. It has to run smoothly, harmoniously, and without any jerks. And that's something I pay special attention to as well, making sure we tune the engine and transmission together so that everything runs as perfectly as possible without any noises or vibrations, so that it's just great. All right, Andre has already strapped it down. As you can see, we're measuring the rear axle. Here's the eddy current brake again. The roller is being braked. You can also see that the wheel is pressing against the front roller and is being synchronized. Here at the axle, we've used the hydraulic cylinder to apply 5 tons of downward force, so it really has traction. Now we're going to use our app to activate the test bench mode so that the front axle is locked and we can take direct measurements. The season will start later, but we'll see each other again in a month. We've now done the initial measurement. Let's take a quick look at it together. You said the car has 370,000 kilometers on it, and for that, the initial performance is really perfect. You can see it down here again, from 800 to 2,000 revolutions, so 1,200, 1,400, 1,600. The lower curve is the torque curve, and the upper curve, as you can see, shows that the peak power increases with rising RPM. That's the horsepower, or converted to kilowatts. Here we can also see the torque axis, so you can compare it here, and with increasing RPM, the horsepower output here. As I mentioned, the car is rated at 480 horsepower and 2,300 Newton meters of torque. That's exactly why I say it's truly a perfect result. We even have an impressive 60 Newton meters more torque, so that's a total of 2,360 and 476 horsepower. Of course, these are the ideal conditions for us to fully optimize the car, the new. A customer complained that he doesn't see anything at the lower end. This is also due to the transmission, where the shift points, the connection points, are too low and the engine's bogged down. You can see that clearly here on the curve. You can see it here. It reaches its maximum torque at 11,000 RPM and holds it until 14,500, then it starts to drop off slightly. But that's exactly the area here where the customer also complained, and as we can see on the test bench, that's where it's lacking a bit. All right, then I would say, let's flash it now using the app. And I'll show you that really quickly. I'll take you along for a moment. Once we've reprogrammed it, we'll do the initial measurement right away, and then we'll see each other again at the monitor. We're now on the passenger side of the truck. You can see the Mercedes here. They all actually have, even the old MP1 to MP3 or MP2, MP3, their OBD port down here, just like the MP4 and MP5 as well. Always the same principle. Ignition on, plug in the adapter, and only then open the app. So I've already done that here, and now I'm going to connect here with Mercedes-Benz. Now the adapter is searching. You can see how fast that goes. In the background, my sucked CLC automatically pulls out the VIN and everything else. So now let's go here. You can see here we now have eco optimization, eco and power for the engine, and also for the transmission, both eco and power. This way, the customer can individually decide what they want to do. The customer now wants to save fuel, the torque at the lower end. I've now stored a special version for him. I can also go ahead and store a custom map for the customer in our app. This way, the customer can tell me exactly what they would like or what they are dissatisfied with, and then I can go ahead and adjust it in the specific areas. Now, for example, with him, the main focus is a bit lower down. So we'll keep the peak torque the same, and we'll also keep the peak power the same, even more in the lower torque range. I'm already starting to flash it. As I said, I've explained this in enough detail in other videos. I don't want to go into too much detail about it now. We'll do the transmission, then we'll do the baseline measurement, and after that we'll meet at the monitor. We've done the baseline measurement. Let's take a quick look at it together. I just spoke with the customer again because we had looked at the diagrams together beforehand. He sometimes said the truck is moody, sometimes it runs well and sometimes not so well. And we actually noticed that here on the test bench. Let's take a look at it together now. As I said, down here you see the RPM axis, here the horsepower axis, and here the torque axis. The red curve is the original, and the blue curve for the torque, that's the optimized one. We have a maximum torque of 2,737 Newton meters compared to 2,360 Newton meters. So that's almost 350 Newton meters more torque. So that would be perfect. But as you can see here, we have significantly earlier torque, but it drops off here in the middle. And that's a bit of a well-known problem with the VTG adjustment of the turbochargers, that it sticks. And that's exactly what the customer has actually complained about. This reflects exactly what we're seeing here now. It kind of drops into a hole, and that's when the VTG controls the wrong airflow, the lambda correction value doesn't match, and then the engine control unit reduces the power so that it doesn't run too rich or too lean. So you can see this area here, we couldn't really measure it properly because it kept dropping into this dip. If we had measured 10 more times, maybe there would have been a measurement where it was good again. But still, it does have a problem. I've always said he should definitely have a workshop check it, because of course that's also really bad for fuel consumption. So the peripheral systems always have to be 100% in order for the vehicles to run as efficiently as possible in terms of fuel consumption. That's obvious. Turbocharger. What does the engine need? Air and diesel. Air comes in through the turbocharger and diesel through the high pressure pump and the injectors. That's a basic requirement for the engines to run perfectly. All right, there's nothing more we can adjust here. But you can see the basic performance is right. I'm satisfied with the result as it is. That's exactly how it was programmed in. I've stored a custom version because he just said, I go for more low end. You can really see that quite nicely here. At 800 revolutions per minute, he almost reaches the maximum value he used to have at a full 1000. You can actually see this quite clearly. On the original curve, there's a slight dip. And here, with the optimized version, because it builds up pressure faster, you can see it even more clearly. That's also something we can always do with the test bench. Especially when a customer complains about something that can't really be determined from the outside, I can always diagnose it 100% on the test bench. Because then I can see exactly what the truck is doing in terms of torque or where it really has a problem. That's the great thing about the test bench. For example, I could use diagnostics, take measurements under load, and really trigger individual actuators or injectors again. Or I can look at the target and actual values under load using the log values to see exactly where the problem is. So it's actually very easy to pinpoint, because the problem often is that when the customer goes to the workshop and complains about something, it's very difficult to simulate for the mechanics to replicate as well, because you don't always have the same constant load. Even when you're driving uphill with a load, it's still not always consistent. And that's what's great about the test bench. I can really set a fixed RPM, accelerate it steadily, hold it there, even hold the engine at a constant, and then check if all the peripheral values are 100% correct. And yes, we've already done a lot of warranty measurements for the manufacturers as well, especially to rule out things like that. All right, then the customer will now get the app from me. I've given him the instructions as far as needed. I'm satisfied with the result. I hope the customer will see it that way too. I'll call him later after driving for a week or two to get his thoughts on the fuel consumption and the transmission optimization. And maybe also whether he's already fixed the problem with the turbocharger. And then we'll just have to wait and see what he says about the fuel consumption. We've reached the end of our video about the engine and transmission optimization of the Mercedes-Benz Actros 1848. The customer will also get the app from me now. And of course, you also know about our special Schaknat Hugo Bustorf air fresheners, naturally from the MP5 Actros. As I said, they smell really good, and customers always like to have them. If you're interested in this topic, feel free to check out our website at www.schaknat.com. We're happy to advise you by phone, or feel free to send us a WhatsApp or an email. I hope you enjoyed the video. Feel free to leave a comment below about what you'd like to see next. Thank you for your attention. Take care, everyone. See you next time. Ciao.